All right. Good morning, everyone. Good morning. Hope everybody's doing good. Everybody's all right. Let me cut out. Oh. All right. Hope everybody's doing great. Everybody's ready to get into the weekend. So we're looking at 4.2 today. In the last class we did 4.1, where we closed out with 4.1, and that was simple interest. So today we'll look at compound interest. And you see off the top, the compound interest formula is a little more involved than the simple interest formula. So here we have, but we're going to be using the same letters. We're going to introduce a new one, which is N. But A is going to be your total amount or future value. E is your principal. R is your rate. T is your time. And N is the number of compounding periods per year. And so, just how many times is the interest rate going to be applied to money, per year. Compound. Yeah, that's what it is. Hmm. Thank you. So we have A equal to P times 1 plus R over N raised to the N times T power. So that N times T is an exponent. All right, scrolling up some. All right, so when it comes to N, normally they don't give you the number. They use a word or keyword that lets you know what number to use for N. So when you look at N, if you see that it's compounded annually, then that means N is equal to one. That means only compounded once a year. Semi-annually is twice. Quarterly is 4 times. It's 4 quarters in a dollar. Monthly 12 times. Weekly 52, and then daily 360. Just like we talked about last class by using Banker's rule. 360. All right, scrolling up. If I go up too far, of course, let me know. Okay. Take your time. Yep, scrolling up some. All right, let's look at the first example. You deposit $7,500 in the savings account that has a rate of 6%. The interest rate is compounded monthly. How much money will you have after 5 years? Anybody holding on to the blue? Blue up top. All right, so just like I did with last section, you want to label out the given pieces of information, make sure you assign them properly to the right variables. Your deposit is your principal, that's P, 7,500. Your rate, 6%. You want to go ahead and convert that to a decimal. That's point, before you put it into your formula and calculator, that's 0.06. Says compounded monthly, so that means N is going to be 12. And then the time is 5 years. How much will you have in your account after 5 years? Now, as you go about doing these problems, make sure you have something reliable to, we talked about that last class as well. Make sure you have something reliable. If you don't know how to use the calculator that you have, make sure you get with me. Pretty sure I can help you out with that. You'd probably be easier if you came in class. So I can, walk you through the steps, and we can even write out steps for the calculator that you have specifically. But certain calculators, because we're going to end up using the exponent, certain calculators have a button that have X to the Y. Some of them have two squares, one that's raised up to the other. So it just depends on your calculator and the type of functions that it has. Or like I mentioned before, you can use something on the web like Desmos, in which you can just type it in and they have the buttons. So, just depends on what you have at your disposal. Scrolling up some, of course, as always, if I go up too far, let me know. So we want to know how much money, in other words, what is the future value of the money that's in this account after 5 years? So our formula is A, remember A represents future value, equal to P times 1 plus R over N raised to the N times T power. So you can put it in your calculator just like this, 7,500 times 1 plus 0.06 divided by 12. This here, we call it a caret. Sometimes we call it a hat, depending on who's talking to you. But it's that raises what comes next to the exponent, and you're gonna have to use parentheses in order to do 12 times 5 as your exponent. And put it in the calculator like that, and you should get your answer. 10,116.38. And don't forget, we're dealing with money, so hundreds place should be what we round everything to, unless they tell you something specifically. So we're always going to hold on to those cents. Scrolling up some. So B, part of the same question, find the interest after 5 years. So the first one asked about the future value. So that's the principal plus interest. So whenever we have these type of situations, you have money that you start off with, and then you have interest earned. So A is always the money that you started off with plus the interest earned. So when we look at what they're asking for in B, we want to know what was just the interest earned after 5 years. So we take A, which is the interest plus your principal, and then we subtract the principal from it. And that would let us know what was the interest earned. And so the 10,116.38 minus the 7,500 gives us 2616.38. So that's how much money was earned over the 5 years. Scrolling up. All right, so another formula is continuous compounding. So continuous compounding is different than daily compounding. Continuous compounding will say continuous compounding. So when you go about doing these word problems, dealing with simple interest, compound interest, you got to make sure you're paying attention to the wording. So, one word here versus another word there will change what you do and what formula you use. Once again, simple interest was all 4.1. Compounding interest is going to be the formulas in this section. So, and then when you look at continuous compounding, that's this formula right here, A equal to P times E to the RT. And E is not going to be a variable, it actually represents the exponential function. So if you have a scientific calculator, you will see something along the lines of E to the X, or maybe E with the little square up that represents the exponent that you will be using there. But it is an exponential function. So we're not going to plug in a value for E. E has its own value and its own application. P, this is uppercase. Let me scroll up on the red. All right, so let's look at this example. It says you decide to invest $8,000 for 6 years and you have a choice between two accounts. The first pays 7% interest 7% per year, compounded monthly. The second pays 6.85% per year, compounded continuously. Which is the better investment? So for those who are copying that, give you a chance to write. All right, are we good on the formula? Very good. All right, so we have two different accounts, so that means we're gonna do two different calculations. The first one pays 7% per year compounded monthly. The second one pays 6.85% compounded continuously. So not only do we have two different accounts, but we have two different formulas for our two different calculations. Once again, one is compounded monthly, so that was the first formula that we were introduced to. The second one is compounded continuously, so that's the second formula that we were introduced to. All right, so if I scroll up too far, just let me know. All right, so that's the first calculation. First account. Now we have $8,000, so $8,000 is going to be the principal, regardless as to which one. We're just trying to figure out what we're going to do with the $8,000. So P is 8,000, R 7%, 0.07. That's a decimal. T is 6 years, and then monthly is 12 for our N. And we see the formula over here. 8,000 times 1 plus 0.07 divided by 12, raised to the 12 times 6 power. That gives me 12,160.84 cents. All right, can we scroll up on the black? All right, so the second account was continuous. Once again, P was 8,000. Our rate this time is 6.85%, so it's 0.0685. Time was still the same, so we're still dealing with 6 years. But this time, we're looking at continuous compounding. So if it's continuous compounding, we don't have a number for N. That means we're going to use a different formula altogether. That's P times E to the RT. And that's a power. RT is your exponent. So it's 8,000 times E raised to the 0.0685 times 6. And really what we could do right here. So once again, it's 8,000 times E raised to the 0.0685 times 6. And that'll give you $12,066.66. All right, any questions? Are that good? Still looking purple, some. So just wanted to give you a concluding statement. So first account at 7% monthly compounding is the better investment. So all we did was we compared the two values. You know, the first account gave us 12,160. The second account gave us 12,066. So the first account gave us more money. That means that's the better investment. All right. So up, everybody good? Next formula is just taking the first formula we talked about and solving it for P so that we can calculate the present value. In other words, if I know I want to earn a certain amount in a certain amount of years, how much would I have to deposit today? Or how much would I have to deposit in the present in order to get to that future value? So once again, it's the same formula that we had initially. A equal to P times 1 plus R over N raised to the N times T power. It's just that we take that, solve it for P, and we have A over 1 plus R over N raised to the N times T power. That's equal to P. Statement red, statement red. All right, so how much money should be deposited today in an account that earns 6% compounded monthly so that it will accumulate to $20,000 in 5 years? So once again, you got to pay attention to keywords. They're going to tell you if they want you to find a future value or they want you to find out what's going to be deposited today. That means you're talking about present value. Mhm. Y'all hold on to the formula. Right. So once again, when it comes to these word problems, I'll let you go ahead and list out what each letter represents based on the given information that we have. So my P is what's going to be unknown, because that's why I want to know, what am I going to deposit today? R 6%, so it's 0.06. T is 5. N is 12 because it's monthly, and then A is 20,000. All right, plug it in. So that's A over one plus R over N raised to the N times T power, 20,000 over one plus 0.06 over 12 raised to the 12 times five. That gives you 14,827.4439. All right, so when dealing with present value, we're always going to round it up. So our final answer is going to be 14,827.45. Now, if they tell you to round up to the nearest dollar, then you would take that seven up. But you're always going to round it up because what happens here, if I were to put in this value, what the calculation says, if I put in this value, that's how I'll get to 20,000. But if I were to round down and take off this 3.9, then I'm not going to get to 20,000. I will come up a little short, even if it's a little tiny bit short. We're talking about actually getting to 20,000. So I actually need this 3.9 behind the 4.4. But if we're dealing with cents, I do have to round to the hundredths place, which is the second decimal value. And so I need to round up to secure that I'm able to reach 20,000. Now, this value should actually give me a little over 20,000 because it goes over what we initially had, but that secures the 20,000 versus us coming up short. Everybody good, everybody straight. Yeah, one more formula. Let's roll up. All right, so effective annual yield or effective rate. It's a simple interest rate that produces the same amount of money in an account at the end of 1 year as the end account is subject to compound interest at a stated rate. All right, so our formula is y equal to 1 + r/n raised to the nth power minus 1. And the result should be converted to a percent. All right, let's pull it up. All right, so we have a passport savings account, has a rate of 5%. The interest is compounded daily. Find the effective annual yield. All right, so once again, we have a passport saving account that has a rate of 5%. The interest is compounded daily. Find the effective annual yield. So our rate is 5% and it's compounded daily, which is 360. All you need is RNN. So that'd be 1 plus 0.05 divided by 3060, raised to the 360 power, minus 1, and that'll give you 0.0513, which is 5.13%. All right. So questions, anything, everybody good? Those are the formulas. Those are the only formulas that I saw that you should need out of the section. Try it out, see if you have any issues. Of course, if you see anything else, let me know and we'll make sure we cover it. But yeah, those are the only ones I saw that you would need for this section. All right. So if you have some questions, feel free to stay back. If not, that's all I got for today. Have a great weekend, be safe, and for those who are looking for the videos, I'll be sending them out between today and tomorrow. Have a good one.